Good morning friends, welcome to Pannika's Tutorials YouTube channel. In the last video, I have discussed how to insert elements in the red black tree or how to create a red black tree. I hope you have watched that video. Lot of students face the difficulty to understand the red black tree creation. So that's why in this video, I am discussing another example so that you will understand the concept in a better way. So I request everyone to watch the video completely for better understanding. So let me discuss these rules. Already in the last video I have discussed all these rules, but again we are discussing another example. So let me discuss these rules. What are the rules you need to follow when you are creating the red black tree or inserting elements in the red black tree? The first thing is that if tree is empty and you are trying to insert a new node, create a new node as root node with color as black. Now let's take the 12 I want to insert. Currently the red black tree is empty, so I can create the 12 as a root node and make it as a color called black. This is the first point. Okay, now you want to insert 19. Now if you want to insert 19, where you need to insert? Red black tree is a self-balancing binary search tree. What is a binary search tree? The node which is there in the root node or it is a parent node, the left subtree should have the elements which are less than 12 and the right subtree should have the elements greater than the 12. Suppose let's take that you have a node. You will have the left subtree of the node and you have the right subtree of the node. Suppose if you have, let's take that value 50 here, then all the elements in the left subtree should have the values less than 50. In the right subtree, you should have the values greater than the 50. That is the point of the binary search tree. Now, if you want to insert 19, 19 is greater than 12, so you need to insert to the right. Now, read the second point. If tree is not empty, now you want to insert 19, now the tree was not empty because already 12 is there. Create a new node. Yeah, we have created a new node as a leaf node with color as red. Okay. You are making this color as a red. Now look at the third point. If the parent of new node, this is our new node, the parent of new node is this one. If it is black, then it is okay, you can leave it. Okay, so in our case, this 12 is black, which is a parent of 19, so I can leave it. Now I want to insert 7. Where should I insert 7? 7 I should insert to the left of the 12 because 7 is less than 12. Now again you are creating a new node for the tree which is not empty, then you make it as a leaf node with a color as red. And then you need to look at the parent's color. What is the parent here? 12, whose color is black. If it is black, you can leave it as it is. Done. We have inserted 12, 19, 7. And now you want to insert 16. If you want to insert 16, the tree is not empty. So you need to insert 16 at an appropriate position where 16 is greater than 12, less than 19. So you need to insert here. As it is a new node, you will make it as a red color. Are you able to follow it or not? If tree is not empty, create a new node as a leaf node with color as red. Now you need to check the third point. If parent of new node is black, parent of new node is not black here, is red. If parent of new node is red, then color of the uncle we need to check. What is meant by uncle? This is the new node. Okay. New node uncle means new node's parent and its sibling. Is it clear? This is the parent and its sibling. Parent's sibling. That is important. Color of uncle means color of parent sibling. This is the parent and its sibling is this 7. Now what is the color? Now let me write this is the uncle for the new node. Now you need to check the color of the uncle. If the color of the uncle is black, you need to follow these steps. If the color of the uncle is red, you need to follow these steps. Now look at the color of the uncle is red. Then recolor the uncle and parent of the new node. What is meant by recolor? If the previous color was red, you need to make it into black color. That is meaning of recoloring. If the previous color was black, Now you need to recolor into red. That is the meaning of the recoloring. Now to whom you need to recolor? You need to recolor the uncle and the parent of the new node. This is the new node. Its parent is this one, which was red. Now you need to make it into black. And the uncle's color was red. Now you need to make it into black. Are you able to follow with me or not? Okay. And then once it is done, and also check if grandparent of new node, this is a new node, parent is this one, grandparent. If it is not root node, then recolor it and recheck it. If it is root node, then you can leave it. Now listen carefully. And also check if grandparent of new node is this one, grandparent of is this one. If it is not root node, then you need to recolor and recheck. But if it is root node, then you can leave it. Are you able to understand? So this is about a red black tree after inserting 16. Okay, are you able to understand? Now you need to insert 17. Where you will insert 17? 17 is greater than 12, less than 19, greater than 16. So here 17 will come. As it is a new node, you will make it as a color called red. Now look at, there is a red conflict, meaning is that the parent of new node is red. Then you need to check the color of uncle. What is the uncle? This is the new node. Let me write it as NN. New node parent is this one. Its sibling is this one. Am I right? Meaning is that this is the uncle. But as there is no node, so you can consider it as a null node, which is a black in color. Already I have discussed this point when I was introducing the red black tree. That is more important. If the color of the uncle is black or null, this is null, which is a black, then do suitable rotation and recolor. So which is a black. So you can do the suitable rotation. Already I have discussed several rotations in the AVL tree. Those rotations are 4 rotations, which is LL rotation, LR rotation, RL rotation, RR rotation. Is it clear or not? Now you need to check which rotation you need to follow. Now 19's left and then you are going for the right. So you need to go for the LR rotation. Is it clear? If it is LR rotation, we will do the first RR rotation, then we will do the LL rotation. Let me do that one with this example. Let me take the 19. You have a 16 and you have the 17. So first you need to do the RR rotation. So you will take 16 and then you will take 17 and then I think it will not be visible for you if you write it here. Let me write here. Okay. I need to do RR and LL. First I need to take 16 and then 17 and then I will take a dummy variable to make it easy for RR rotation. First I need to do the RR rotation. What is meant by RR rotation? I will hold this 17 and I will move this 16 to the left side. So if I do it, I will get 17 here and 16 here and a dummy element. Then I will add this 19 and then I will do the LL rotation. The need for this dummy element is completed. To make you understand how to do the RR rotation, I have taken this dummy element. Okay. Now if I want to do the LL rotation, I will hold this one and I will move this 19 to the right side. Then I will get 17, 16 and 19. Now you need to check the color of 19, which is black. Let me write it as B. Okay. And 16 color is red. 17's color is red. Now what is the final rotation we have done? We want to do the LR rotation. First we have done the RR rotation, then LL rotation. The final rotation is LL. So when we are doing the LL rotation, we got this one. After doing it, we got this one. So these two colors, this one and this one color, you need to recolor it. That is what the point is. After rotation, you need to recolor. These two colors, you need to recolor it. So 17 was red. So now you need to make it to black. And 19 was black. You need to make it to red. and 16 was red, you can leave it as red. Please remember this point. These two colors you need to recolor them. So you need to erase this one and you will get 17 here, which is black in color. Okay, and you got 16 which is red in color, and you got 19 which is red in color. After inserting 17 we got this much. Which one we have inserted? We have inserted 17, huh? Yes, correct. Now check it. If you want to check the properties of red black tree, you are free to check it. But I am damn sure that it will satisfy all the properties of the red black tree. What is the properties? The first property is that each node should have a red color or black color. Look at all the colors, all the nodes I have represented with a red or black color. What is the second point? The root node, which is 12, should be in black. It is already in black. And the third point is that there should be no two adjacent with color called red. Here red and black, black and black, red and black. So there is no red conflict. And the next point is that from the any node, including the root node, if you are going to any descent null node, the same number of black nodes you should visit. Now if this is the descent null node, 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 this is the descent null node. If you want to visit this node, you need to go from this path. How many black nodes you are visiting? 2. For this one also 2 black nodes. For this one, 1, 2, so 2 black nodes you are visiting because this is red. So this is 2. This is also 2 black nodes, this is also 2 black nodes. So I can say that for all the descent paths, even from the every node, including the root node, you are visiting the same number of black nodes. So I can say that it is the proper red black tree after inserting 17. So this was red. Let me change it as to red, and we will do the insertion of remaining elements. We have inserted up to 17. Now I want to insert 40. Where should I insert 40? 40 is greater than 12, greater than 17, greater than 19. So 40 will come here. Okay, which should be in red in color. Now there is RR conflict because the parent of the new node is red. Then check the color of uncle. What is uncle? This is the new node. New node parent is this one. Parent sibling is this one. So this is your uncle. Okay, new node's uncle, not our uncle or your uncle. This is new node's uncle. Now, if the color of the uncle is black, then you need to follow these steps. If the color of the uncle is red, here our uncle color is red. Okay, then recolor the uncle and parent of the new node. Recolor the uncle, meaning is that uncle color was red, we need to recolor it into black. And this is red because we need to recolor the parent also of the new node. Red, I need to recolor it into black. And also check if grandparent of the new node, is 17 because new node's parent is this one, grandparent is this one. If it is a root node, you can leave it. If it is not a root node, then recolor it. Recolor means it is black. I am modifying into red color. And then you need to recheck it. Recheck it means whether you have any adjacent two nodes have red in color. There is no red in color. Here it is black, it is red. Here it is black, it is red. So it is done. So we have inserted successfully 40. And you can check it, it is a red black tree. Now I want to insert 35. Where should I insert 35? 35 is greater than 12, greater than 17, greater than 90, less than 40. So you will insert 35 here. As it is a new node, you will make it as a color called red. Okay, are you able to understand it or not? As it is in red color, so there is a parent which is red in color. If the parent of new node is red, then check the uncle's color. Uncle is this one because parent sibling. This is the new node, parent sibling, which is null. Am I right? If it is null, then do the suitable rotation. Suitable rotation means from 19 you are going to right, and this is left. So you need to do the RL rotation. RL rotation means first you will do the LL rotation, then you need to do the RR rotation, and then you need to recolor it. Okay. Now as I need to do the LL rotation, I need to take 19. Let me take here. I have a 19, 40 and 35 is there, which is RL. So I will first need to do the LL rotation. So first I will take 40, 35 and a dummy variable I will take, and I will do the LL rotation. If I need to do the LL rotation, I will hold the 35 and I will move this 40 to the right side. So I will get, let me write here, 35, I will get dummy variable and I will get a 40. Then I will insert this 19 and I need to do the RR rotation, because after LL you need to do the RR rotation. The need for the dummy variable is completed. Okay, if the need is completed, you can erase it and you need to do the RR rotation. If I do the RR rotation, I need to hold this 35, which is a middle element, and then I need to move this 19 towards the left side. If I move it, I will get 35, 19, 40. So after doing the RL rotation, I got, instead of this one, I got this one. First look at what is the colors of 19, 40 and 35. 19's color is black. Let me erase it. It is black. 40's color is red. 35 color is red. Now you need to recolor these top two elements. Okay, please note down this point. Okay, recoloring means, after rotation, recolor means what is the final rotation you are doing. Those two elements you need to recolor them. 35 was red, now you need to make it to black. 19 was black, you need to make it to red. 40 is already red, you can leave it as red. So you need to remove this one. Okay, and you need to add 35, which is black in color, and 19, which is red in color. 40 is red in color. Okay, so after inserting 35, we have inserted 35, we got this one. You can check it, it is a red black tree. If you have a doubt, you can cross check it. Root node is root node should be black, it is black. There is no RR conflict, and for any descent node, the number of black nodes is same. Here it is 2, here also it will be 2, and here also 2, here also black, 2 blacks, 2 blacks. So same number of black nodes, which is 2, so it is correct. Okay, so I can say that this is the red black tree after inserting 35. Now let me insert 50. Where should I insert 50? Always I need to traverse from the root node. 50 is greater than 12, greater than 17, greater than 35, and also greater than 40. So I need to insert 50 here. And as it is a new node, I need to make it as a red in color. Now if the parent of the new node is red, this is red, which is a parent of the new node, then you need to check the color of the uncle. This is the new node, let me represent it as NN. This is the parent sibling is the uncle. If the uncle's color is red, then recolor the uncle and parent. Recolor the uncle. Uncle's color was red, now you need to make it to black. And recolor the parent also. Parent color was red, you need to make it to black. Okay, this was the new node. Now, and also check the grandparent of the new node. This is the new node, grandparent is 35. If it is not root node, if it is not a root node, then recolor it. It is black, so you need to make it to red. Now you need to look at recolor and check it. Now there is an RR conflict. Now if it is an RR conflict, this color you changed it. make this as a new node for your understanding purpose. Just for your understanding purpose, I am writing it as a new node, and then you do the appropriate. If it is a new node, parent is this one, sibling uncle is this one. So this is the uncle of the 35. Just for your understanding, I am making it as a new node. Why it is? So that this color is changed. It was previously black and it was now red. Because of this red, there is a red conflict. Am I right? So that you need to follow the same steps again. Now, uncle's color was black. If it is black or null, then do the suitable rotation. Suitable rotation means this is L and L. You need to do the LL rotation. LL rotation means you need to hold this 17 and move this 12 and 7 towards the right side. Okay. Sorry, to the right side. Right rotation you need to do. Oh, sorry. This is not LL rotation. Sorry for it. This is RR because these are the right. Okay. So you need to do the RR rotation. What is meant by RR rotation means you hold this one and move to the left side. Okay. So if you move to the left side, please remember these colors. 12 color is black. As there is no space, I need to erase it and do it. 7 color is black. Okay. 17's color is red, 16 color is black. Now if you rotate them towards the left, then the 12 will come here, okay, 12 will come here and 7 will come here and 16 will come here. Will you agree with me or not? Those who have watched my AVL tree rotation, they can understand how I perform the RR rotation. Now make the colors. 12 color is, you can need to erase this one. And remember one more point. After doing the rotation, you need to recolor. What is the colors you need to rotate? These two colors you need to recolor them. So which is red, you need to recolor it into black. Okay. And you can erase. 12 color was previously black. So 12 color you will make it into red. Write this one. And 7 color was black, you will leave it as black, and 16 color was black, you will write it as a black. So after inserting 50, you got this as a red black tree. Now you can cross check all the rules are satisfying for the red black tree or not. What is the first rule? Every node should be represented with a color either red or black. You can look at all the nodes I have represented either color called red or black. What is the second rule? The root node should be the color called black. Here the root node is 17, which is colored as black. So the second rule is also satisfied. What is the third rule? There should be no red conflict. Look at, there was no red conflict, meaning is that no two adjacent elements are red in color. Means if the parent is red, child should not be red in color. Now, what is the fourth point? Any descent node, if you are visiting, it should be same number of black nodes you should visit. Now, if you want to visit any descent node, because here one leaf node which is empty, so there will be a descent node which should be in black in color. So, 1, 2 black colors you are visiting. Even if you include that one, it will be 3. I am not including because all the descent nodes which are empty will be null only. Now, 1, 2, 2 blacks. 1, 2 blacks, 1, 2 blacks here, 1, 2 blacks here. So all the descent nodes, if you are traversing from any path, you are visiting with same number of black nodes. Even the fourth rule is satisfied. So I can say that after inserting these elements in a sequence, we got this as a red black tree. I hope with these two examples, you have understood how to insert elements in the red black tree. If you still have any doubts related to this red black tree insertion, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.